Good afternoon. Today we continue on addition and subtraction of volumes of solid shapes. So we are going to take more examples on that subtopic. Number 1. A solid cube of side 8 cm is dropped into a cylindrical tank of radius 7 cm. Calculate the rise in the water level if the original depth of water was 9 cm. Now the solution. This is your cylinder originally containing 9 cm of water. The radius is 7 cm. This is your solid cube of side 8 cm. After dropping into the cylinder with water, you will generate something like this. When you drop this cube into this cylinder containing water at this level, the water level will rise to this new level. So, but the new height is what we don't know. Originally, we were given that the depth of the water was 9 cm. But after dropping the water, after dropping the cube into the water in the cylinder, the water in the cylinder will rise to this new level. So we have to calculate the rise in the water level. Call the new height of the water in the cylinder H. Let's call this one 1. Call your cube diagram 2. Call what you have here to be diagram 3. Now, get the volume of your cylinder. Volume of cylinder in 1 is the same thing as the water in the cylinder will be the volume of that cylinder, and that will be pi r squared h. Pi is 22/7 times your 7 squared times 9. 7 squared is 49. 7 will cancel 49 to give 7, and we will have 1386 cm cube. Volume of your cube in 2. Volume of cube is length times length times length. That will give 8 raised to power 3, which is 512 cm cube. Now, the water in the diagram 3, after dropping the solid cube inside it, that rises to this level, we also take the shape of the cylinder. Therefore, the water will also be gotten the volume of the water by taking the volume of the cylinder, which is also pi r squared. That is 22/7 times your 7 squared. The radius of the cylinder will not change, but the new height is what we don't know. And that will give us 154 h. Now, when you check this diagram, you discover when you drop this cube into the water in the cylinder, it's like adding the volume of your cube to this volume of the water in the cylinder. So to get this new shape, and that is why I am saying diagram 1 plus diagram 2 to give diagram 3. Diagram 1 is the volume of the water in the cylinder, which is the same thing as volume of your cylinder, which is calculated to be 1386. Number 2 is the volume of your cube, 512. Diagram 3 is the volume of the water in the cylinder with height h, which is 154 h. Then you add this to give this, divide through by 154 h, and the height is 12.32 cm. But we are to get the rise in the water level. The water, which was originally at this level, rises to this level in this. So the rise is from here to here, this new level, that which is the same thing as saying the height, the new height minus the original height, and that is h minus 9, which is 12.32 minus 9, which will give us 3.32 cm, and that is the rise in the water level. Number 2, a fish tank is in the shape of an open glass cupboard 30 cm deep with a base 16 cm by 17 cm. These measurements being external. If the glass is 0.5 cm thick and its mass is 3 grams per cm cube, we have to find the capacity of the tank in liters and the mass of the tank in kg. Draw your fish tank. It will be like this. It is a hollow solid. The external dimensions are given: the length 17 cm, breadth 16 cm, the height 30 cm. The thickness is 0.5 cm. Get your internal dimensions. Now, if I want this my internal length, the simple thing I will do is to subtract my thickness 2 times from my external length, and I will have the internal length. That is 17 minus 2 times thickness. That is thickness twice. Look at it. This thickness, remove it from this thickness. This thickness and this thickness, add them together and remove the two of them from the external length to give you the internal length, and that will give you 16. Similarly, the internal breadth will be gotten if you remove the thickness here and this thickness here from internal breadth, which is 16. It will give us this internal breadth, and we'll have 15 cm. That's what you have here. Why the internal height will be gotten by subtracting the depth, the thickness once from the external depth. You subtract your thickness once from the external depth, and that will be 29.5 cm. Now that we have our internal and external dimensions, the shape is a keyboard, so your volume using internal dimensions will be LBH, your internal length times internal breadth times internal height. That gives 7,080 cm cube. Using your external dimensions, we use LBH. Those dimensions were already given. That is 17 times 16 times 30. That will give us 8,160 cm cube. Now, when you hear capacity, that is A, capacity of the tank is the same thing as the volume of the tank, which you get by subtraction of volumes. That is the volume using external dimensions minus the volume using the internal dimensions, and that will give 1,080 cm cube. But you have to get it in liters. Since 1,000 cm cube is 1 liter, you divide this by 1,000, and the capacity of the tank in liters will be 1.08 liters. and that's how you settle that. We are to get the mass of the tank in kg. When you come here, you discover we were told that 3 grams, we were given 3 grams per cm cube, which we call density. That is per cm cube. That's 1 cm cube will be 3 grams. So if 1 cm cube gives you 3 grams, our volume we calculated here in cm cube, which is 1080 cm cube, will be 3 times 1080 grams, which will give you 3240 grams. But you have to get it in kg, and 1000 grams will give us 1 kg. So you divide this by 1000, and the new mass will be 3.24 kg. When you check, that's how you settle that. I still want to come here. When we did this one in our last class, we were given internal dimensions. To get the external length and the external breadth, you discover we added thickness 2 times to the internal length and the internal breadth to have the external length and external breadth respectively. That's the same approach you use. So this time, to have internal length using your external length and thickness, you will subtract the thickness 2 times from the external length to have the internal length. The same thing, subtract your thickness 2 times from the external breadth to have the internal breadth. Why? When we did for height, that's to get external height. When you have your internal height, we added thickness once to the internal height to have the external height. Now that you have the external height, you will subtract thickness once from the external height, and you have the internal height. So it's just the same approach, and use your normal formula. Thank you.